Welcome to this class. In this class, we will see a little bit about 3D printing. You have seen in detail how the 3D printing works, whether we are looking at the history of 3D printing or subtractive versus additive manufacturing, or types of 3D printing, whether it is SLS 3D printing, SLA 3D printing, FDM 3D printing. We have also seen the modeling software, printing workflow, 3D printing techniques, application of 3D printing, and how the SolidWorks demonstration has also been covered in the TA class. Now, this is a very small lab video where we will show you a quick demonstration how the 3D printer works. So, you enjoy the video and see how 3D printer that we have at our lab works, and do try to understand that whatever is taught in TA, how it will help to finally design a casing or a component in which you can put your sensors or electronics. So, it is like a 3D prototyping, right, because you need to have a prototype before you actually go for the mold and actual product. So, I hope you will like the lab video that we have recorded for you. Please see the video. Thank you very much.
Greetings everyone, welcome back to our NPTEL lecture on 3D printers. In this lecture we will be having a lab section on 3D printers. So in our previous lab sessions we have discussed about different kinds of 3D printers, what all its advantages, disadvantages, limitations, and where all are these 3D printers can be specifically used. Here we will be looking on SLA 3D printers. SLA stands for stereolithography 3D printers. So here we have a SLA 3D printer from Formlabs. The particular model is Formlabs 3BL. So now we'll take a closer look on some of the important parts on a SLA 3D printer. So on the top of the printer we will be having our print bed. It's here our print will be stick on to while it's printing. On coming down at the bottom we will be having our resin vat. It's inside the resin vat we will be pour our liquid resin, that's a photopolymer. It can be either by automatic means or by manual means depending upon which kind of printer we are using. In Form 3BL it will be having an automatic feeding system where we will keep our resin cartridge and it will be automatically fed to the resin tank on demand. So beneath the resin tank we will be having our laser processing unit or LPU. LPU consists of complex laser system and optical arrangement. The optical arrangement is used to scan the laser dot in X and Y direction, completing the cross section of that particular layer. So by scanning the entire cross section we can convert that liquid resin into solid raw material. So once every layer is completed, our print bed will be raised by a particular amount, for example 0.1 mm or even 0.025 mm, and then there will be a gap between our resin bed, the surface of the resin bed, and our previously printed layer. So in that gap our new resin will be coming, and then again the process repeats to create a model that we upload to our printer. So each printer will be having different kind of GUI, but the generic workflow remains the same. In our Forms 3BL, we have a printer GUI screen here. So before putting it for printing, we must make sure that our key components are in place, like print bed is locked, our resin vat is properly secured, or our resin cartridges is in place and it have enough resin to complete the print. So once making sure everything is done, then we can put our print for printing. So here I can just press the print button to start the printing. So in our particular case, this print will take around 1.5 hours to complete the printing. So once it's done, we will be resuming the lectures. Now the print is completed. We can remove the print from the print bed. You can see the print that is attached to the print bed. Now we are removing it with a scraper. Once the print is removed, we must make sure to keep our print bed back to the printer itself, so it will avoid any unnecessary dust on the print bed. Now we can see the residual resin that is stick on to the printed part. So we need to give it an IPA bath or a rubbing alcohol bath for around 50 minutes. So here we have a rubbing alcohol station. In the bottom of this bathing station, we will be having blades which will be continuously rotating to create a vortex effect. So it will make sure that IPA will reach every corner of our printed part to clean it thoroughly. So I'm placing it in the station. We can keep it for around 15 minutes for a complete cleanup. Once the washing is completed, I have kept the print part outside for around 30 minutes, so it will help in evaporating of IPA. Now we can remove the support materials. So I am using a snipping tool to cut the support materials. Once the support material is removed, if want, we can give a little bit of sanding, so we will be having much more smoother surface finish. Now the final step is curing our printed part. We will be keeping it under UV light for around 30 minutes with temperature of around 60 degrees Celsius to completely cure our part. So we will be having a UV curing station here. We'll keep our parts here. Once curing is completed, your entire post-processing procedures are completed. So now you can use this part in your actual use cases. This entire procedures might differ a little bit depending upon which kind of printers you are using, but the entire workflow remains the same. So this is actually how you can convert your idea into a 3D part in the real world using SLA 3D printers. So that's all for this lecture. If you have any doubt, you can contact us through our portals. We will be happy to assist you. Thank you.